Alright gang, this is going to be 2-3 and I'm looking to, my plan is to just do the, just like in class, in case you missed class, just do the 2-3 parts and pieces, and then make a separate video for the 2-4 material, but it's all on the same notes handout, this handout. And so here we go, 2-3 about linear equations, and this is going to be more review from your previous math class. And we start with a little bit of recall. It's probably all recall, probably. But recall that a solution, that's a pretty specific word. It's more specific of a word than you might even realize right now as far as like math vocabulary and what it's talking about. So here we go. Here's what this is talking about. Recall that a solution is what you can replace the variable or variables with to make the equation true. That's what a solution is all about. It's not necessarily, you can't exactly just loosely replace the word solution with answer or whatever else. Like, again, it's a very specific word in mathematics, and it's whatever that can be replaced, whatever can replace the variable or variables to make the equation or inequality. Not that, I don't want to get ahead of myself or anything, but to make the equation true. So the solution to x plus 3 equals 8, this simple equation, is 5. Because 5 plus 3 actually equals 8, and 5 is the one and only solution here. It's the only number that could fill in for x to make x plus 3 actually equal to 8. So here's the next natural progression, and with a question: what's the solution to the following equation? X plus y equals 6. And you'll probably notice immediately when you start thinking about what's the solution to this equation, you'll notice that there's not just an x variable, but a y variable. So perhaps you're thinking, well, maybe it's not just one number. So this answer basically would be no, it's not just one number. It would take a pair of numbers, if you want to write that down in your own words. You would need a number that would plug in for x, to replace the x, and you would need a separate number to replace the y, and together that pair of numbers would make the equation true. So for example, 4 for x and 2 for y, that pair, and that would equal 6. And so how many solutions are there? So this right here, what's the solution? Maybe a little bit misleading, maybe not the bestest wording, because there's not just one solution. I mean, 4 and 2, what about 5 and 1 plugging in together? So again, what's the solution? That's probably not the best wording, because there's definitely more than just one the solution. And actually, hope maybe by now you've thought to yourself, I think there's, or I know that there's infinitely many solutions. Infinitely many solutions. And by the way, they're not all just confined to the nice integer pairings. And we're going to graph some. So I'm I mean, 4 comma 2 is an ordered pair that can be plotted as a point in the xy plane, right? X-axis, y-axis. Another one I said was 5 comma 1. What about 1 comma 5? Yeah? And 3 comma 3, you know? And like I said, a minute ago, it's not just confined to the really, really nice answers. You could have 2.5 comma 3.5. That's also one of the infinitely many solutions. So what does that make? That makes like 5 solutions so far. So let's graph these now. So 4 comma 2 would go right near. 5, 1, 2, 3, 4, 5 comma 1 would go right there. 1 comma 5 is right there. So we've graphed this guy, this guy, this guy. 3 comma 3 right there. And then 2.5 comma 3.5. 2.5. 1, 2, 3.5. So there's a point right there. So as you can probably see, these points are all graphed like in line with each other. And any pair of numbers that I could think of that would plug into this equation to add up to equal 6, they would all fall on this line. So, I know I'm sort of, advancing the plot here a little bit, maybe more than I should, but the graph of that equation will be a line, because the more points we plot, it's going to just pack together to make this line. In other words, everywhere you look on this line, right there, whatever coordinates those are, would satisfy the equation. Whatever those coordinates are, whatever those coordinates are, whatever those coordinates are, those, anywhere, right? Anywhere on the line. And again, this goes off forever in both directions. And everywhere on there would have a solution. Again, infinitely many solutions. And this definition of a linear equation is an equation, just like the one we were just worked with, like x plus y equals 6, whose solutions, when graphed, form a line. And a linear equation is in standard form if it looks like this. And actually, this is an example of standard form, which essentially just says that we have the x term, and then the y term, and then the equal sign, and then the regular number constant. Just like here, the x term, the y term, the equal sign, and then the constant, where, there's going to be an a value, a b value, and a c value. Even if those a, b, and c values could be things like 0 or 1 or whatever, there's going to be an a value, a b value, and a c value. They're just going to be real numbers, and x is going to be a variable, and y is going to be a variable. So the b value here in this equation is 1. 1y. Okay? And we'll skip this and come back to it in 2-4. And let's talk about slope. This is a big ticket item in algebra, for sure. And this is definitely something that you should be well familiar with, coming out of whatever math class you were just in, or last year, whatever. And slope is basically rise over run. which is the change in y divided by the change in x. Remember, slope is a ratio. It's a fraction. Slope is like the steepness of a line, like how steep is this line. You have to basically describe slope or steepness as how much it's rising compared with how much it's, going forward or whatever. It's you got to have like these two different measurements together. Vertical change divided by horizontal change. This is the coordinate formula that you'll have on your Keystone formula sheet, FYI. And let's do a few of these problems that are in your current 2019 textbook. And so the formula in question is m equals y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. So both of these ordered pairs are x comma y. X comma y. This would be our, in my mind anyway, the first x and the first y. So the first x and y. So this is going to be x1. This is going to be y1. And then over here is our second x and our second y, our second xy pair. So this is going to be x sub 2, and that's going to be y sub 2. And so up here we're going to do 1 minus 4. And don't forget, even especially as we go into the other problems, that there is a minus sign. There's built into the formula. So it's going to be the 1 minus 4 all over 8 minus 5. And so now just simplify it up and stuff. 1 minus 4 is negative 3. 8 minus 5 is positive 3. And so this ultimately reduces to negative 1 as your final answer there. And moving on to the next problem, where you totally feel free to pause and do this on your own, and then continue the video just to make sure. But so here we go. Better pause it. So here it's going to be, there's my y2, there's my y1. So negative 2 minus 2. And there's my x2, there's my x1, which is the same thing as the top. And so we're going to get negative 4 over negative 4, and negative 4 divided by negative 4, or reducing or whatever. I mean, it's clean division. It's not just reducing a fraction, it's clean division. It's going to be positive 1. And the final problem that you might want to do this and pause the video before I go ahead and do it. But so again, this is all just a formula, right? This is as easy as plugging into a formula and letting the formula do its thing. 3 minus a negative 4. Remember, there's a minus built into the formula. And then y1 is negative 4. So we end up with 3 minus a negative 4. And then for x2 minus x1, we got 9 minus 9. So 3 minus a negative 4 is the same as 3 plus 4. And so that's 7. And then, of course, 9 minus 9 is 0. And I hope that you were, pretty much taught this enough or exposed to it in your previous math class to the point where you should notice, like this should jump out at you, literally, no, not literally, but it should jump out at you that we are dividing by 0, that it's 7 over 0, and that is undefined. It's like the one thing in math, as far as you'll know, for going through high school math, that we cannot do in math. It's the only thing in math we cannot do is divide by 0. And in case you're wondering why I just said it the way I did, in calculus you will, like if you end up in Calc 2, there are some other weird things that we call, I believe, indiscriminate forms. And, 0 divided by 0, and I believe another one is 1 to the infinity power. So there's other weird things that you'll get into in a certain section of Calc 2, Calc BC. But please don't worry about that right now. I couldn't help but have that flash into my mind when I said dividing by 0 is the only thing you can't do in math. It essentially is. I mean, as far as we're concerned, for the time being, or for a very, very, very long while, or just maybe overall, only thing you cannot do is divide by 0. Not even Chuck Norris can do it. So actually, we say, I don't even know if writing an equal sign is appropriate. So the slope is undefined. It doesn't exist, right? That is a thing. Slope can be undefined. And essentially, when is a slope of a line undefined? When is it? Do you remember? When it's a vertical line. Vertical lines, you say, have like no slope. Like, quote unquote, no slope at all. Or it's undefined, okay? Slope doesn't exist for vertical lines. Here's a quick, just little mini activity problem that you should probably be able to work your way through based on your experiences from your previous class and knowing what slope means and graphing a point first and just drawing a line that goes through this point. -4, -2, there's the point. And what we would do next is kind of go from this point, and from this point to another point, we're going to draw another point so that between the 2 points has a rise of 1 and a run of +3. So we're going to rise 1, +1, run +3, and make another dot. So from here to here is a slope of 1/3. And we might as well do it again as long as we can make some more really nice points on this grid. So up 1 over 3 again and again. And if there was more grid, if we weren't going out of bounds here and stuff, we could probably go in reverse. Instead of going up and right, we could go down and left and put another point over here, But there's that line. And here's just one more example, and we can go like -3, +3. Remember, it's x-axis, y-axis. Do not mix up graphing x, y coordinates. Don't mix that up with rise over run, change in y over change in x. So anyway. So a slope of -2, remember, slope is best as a fraction, especially when you're working a graph and stuff. So making -2 into a full fraction, you just put it over 1, like always, -2 over 1. So that means our rise is -2, which means down 2. But then the run is +1, so we go to the right 1, and we might as well keep that going. Down 2, right 1, down 2, right 1, and it looks like we can plot that one there nice, and we could actually go like in reverse in the other direction, like going up to left 1 to plot one more nice point. And oh god, oh gosh, oh gosh, my shadow is getting in the way of what I'm doing. Can't see where I'm drawing it. Maybe if I go the other way, my shadow won't. It's a little better, I guess. And I really hope you remember this. Okay? Slope-intercept form. So other linear equation forms other than standard form. So when we mean like other linear equation forms, standard form was the one we already talked about a little bit in this video. And the other ones that are very, 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 very useful, one of them is slope-intercept form. Y equals mx plus b. This is huge, where m is going to be the slope, and b is going to be what? The y-intercept. So the beauty of this slope-intercept form, when equations like this are written in slope-intercept form, you can just look at the equation and go, oh, looks like my m in y equals mx plus b, y equals 3x minus 2. Looks like my m, my slope, is 3. And my b value, my y-intercept, is negative 2. And that's very useful to know, because when it comes to graphing lines, having your equation in y equals mx plus b form is very, very helpful, and it's probably your main strategy based on, I don't know, just what you've already learned. It should be your strategy. That's my advice for sure. And so looking at this equation, for example, it totally already is in y equals mx plus b form, which means we can immediately tell just by looking at the equation that my m value, my slope, is negative 2/3, which is just dandy because slope is a fraction, at its core. And so negative 2/3, that's a totally fine m value that we can work with easily. And our b value is obviously positive 3. And that is more than enough, or just enough, maybe I should say. That is just right, just the perfect amount of information we need to just graph the line. So here's what we do. We begin with b, begin with the y-intercept. And so remember the y-intercept that we could have, sort of defined earlier, but you remember what the y-intercept is. The y-intercept is where the line will intercept or intersect or cross or touch the y-axis. So you start by putting a point right there on the y-axis for b equals 3, because this really means 0, 3, your y-intercept point. And my m value is negative 2/3. Now remember, this negative, we're only going to apply it, so to speak, with the numerator. Okay, it's going to be negative 2 over positive 3, right? Which makes total sense, especially when you think about, what if you decided to apply the negative to both the 2 and the 3? Like, could this mean negative 2 over negative 3? Of course not. because a negative divided by a negative would have overall been positive. So this is just a negative 2 over a positive 3. So we go down and to the right, and it looks like we can even put a dot up here, instead of going like, we can go up and left, I guess. But, so here's my line. And another thing which might help you remember stuff and just to understand this is a negative slope is a line that goes downhill from left to right. And a positive slope is a line that goes uphill, would be a positive slope. Okay. Now this example might be the last example of this video of section 2-3. We also have to graph this another graphing example, but this time you'll notice negative 6x plus 2y equals negative 4 is not in that very, very, very awesome y equals mx plus b form. This is actually in standard form, ax plus by equals c. And unfortunately, standard form, those a, b, and c values don't mean diddly squat. So our first course of action in this example is to change our standard form equation so that it's in slope-intercept form. In other words, solve for y. I don't know why I rewrote this again, but now we're going to take this equation and get y by itself, solving for y. And in doing so, that will basically make it be in a slope-intercept form, y equals mx plus b form. So we add the 6x to the other side, and instead of calling the other side now, because these don't mix, negative 4 plus 6x, they don't mix, they're not like terms, they don't combine. So, but instead of saying negative 4 plus 6x, we're going to say 6x minus 4. So that it like perfectly verbatim matches eventually y equals mx plus b. So we're going to put that x term in first and then the minus 4. And so the last thing we have to do to get y by itself is divide both sides by 2, as you should know already. And don't forget that when you divide both sides by 2, or when you divide both sides by a number, divide everything by 2. So the 6x is going to get divided by 2. The negative 4 is also going to get divided by 2. And of course on the left side, the 2's cancel, so you're just left with y. But on the right side, 6x divided by 2 is 3x. Negative 4 divided by 2 is negative 2. And now we can look at this and go, oh, there's my m value. It's 3, which more specifically, because it's slope, 3 over 1. Okay? So it has a rise over a run. And then my b value is negative 2. And now I can graph this line. So I begin with b. Again, this is like saying 0, comma, negative 2. And I move with m, a positive 3 rise and a positive 1 run. And I can do one more point there, up 3 over 1, and even go in the reverse direction, so to speak, to put a nice point right there. And I don't like that at all. It's a weird angle for me. Oh God, oh God. You know what? I'm smarter than you, Active Board. Sometimes. Gotta get the right color, I guess. Oh, what now? Have some of that. Alright, so that's that one. And we're probably done with the 2-3 material. Actually, maybe we'll point this out right here. All of this stuff, maybe we'll point out quick. Special cases, horizontal and vertical lines. I hope you remember at least talking about this a little bit. Horizontal lines, vertical lines. I'm going to, if you've never heard of this, this is a really neat memory trick. It looks too much like a V. A little bit too much. So here's this memory trick called J.Falk, which kind of sums up the whole deal with horizontal and vertical lines. So the H stands for horizontal, the V stands for vertical, and it turns out that vertical lines, just like it says up above in black and white here, the equations are always x equals some number. That's it. Just like here it says x equals m, where m is just some real number. So x equals -2 or x equals 7. Those are examples of vertical line equations. And the horizontal lines, just like here, y equals n, the y in J.Falk means that the equation is just y equals some number. And not only that, the u over here in Vux means that the slope is undefined or no slope. No slope or undefined. And the O right here in Hoi is actually 0. And because the slope of any horizontal line is equal to the number 0. So don't get this mixed up. Vertical lines have no slope, and horizontal lines have a slope of 0. And that will probably do it for 2-3. And remember, 2-4 is going to be like, I'm just going to pick up where we left off here in the next video with the same handout, of course.